Okay, in this video we're going to work on multiplying mixed numbers, and we're going to multiply those mixed numbers using the area model. We've already done multiplying two fractions together, now we're working on two mixed numbers. Before we jump into two mixed numbers, let's start with one whole number times a mixed number. And again, as usual, I'm hoping that you have a lined sheet of paper and you're writing these examples down, both to refer back to and to get this process into your memory. So the first thing I want to realize is that I can look at this whole number 3, of course it's 3, but I'm multiplying 3 times 2 plus 1/4. I want to be able to look at this mixed number and separate it into the whole number and to the fractional part. I'm going to use that information to make my area model. And my area model here is just going to be a square. And I'm once again going to work with rows times columns. So over here, since I just have my whole number, I'm going to put my whole number 3. But on the top, I'm going to separate my column into my whole number 2 and my fractional part, my 1/4. So now what I want to do is I want to multiply as if I'm doing an array. 3 times 2 is 6, and I'll put the product inside the box. 3 times 1/4 is 3/4. And I put that product inside the box. To find the product of 3 times 2 and a 4, I now need to add my two partial products together. So I'm going to add 6 plus 3/4. And my answer will be 6 and 3/4. Okay, well we're working with a whole number and a mixed number. It's not so bad. But for this next one, I want us to try using two mixed numbers. I'm going to draw a line on my paper so I know that I'm up to example number 2. And this time I want to try multiplying 2.5 times 4 1/3. Once again, I want to split up my number so that I'm dealing with just my whole number plus its fractional part. And of course, I'm multiplying that times 4 plus 1/3. And 4 plus 1/3 will bring me back to 4 1/3. I haven't changed the value of either number. I've just separated them into their whole numbers and the fractional part. I'm once again going to do my area model. I'm just going to draw a square, and I'm going to put my first mixed number as my row size, and my second mixed number as my column for organizational sake to keep things consistent. So I'm going to separate this into 2 wholes and 1/2, and I'm going to separate the top into my 4 wholes and my 1/3. Again, I'm going to multiply, just like an array. 4 times 2 equals 8. 4 times 1/2 would be 4 halves, which we know is equal to 2. 2 times 1/3 is 2/3. And 1/2 times 1/3 is going to give me 1/6. Once again, I need to now take each of my partial products from inside my area model, and I need to add them together. Now, this part seems pretty easy to me. I can see my two whole numbers, so I can add my 8 plus 2. And I can get that 10 right away. But I also have two fractions to add together. And I'm looking at my 2/3 and my 1/6. And I know that in order to add these fractions together, I'm going to need a common denominator. And my common denominator here is of course going to be 6. If you'd like to pause the video to fill in to find your new equivalent fraction that you can add, that would be great, and then just rejoin me once you've done that part. I'm going to add my 4/6 plus my 1/6, which will give me 5/6. So now I put my two parts of my answer together, which would be 10 plus my 5/6, and my final answer is 10 and 5/6. So all I've done here is add each of the partial products together. Here I added my two whole numbers, then I added my two fractional parts. If you feel that you understand this process, then you can stop the video here, and you can move on to your independent practice using the cards. If you feel like you need to do another example with me, I invite you to do that, but I am asking that you're writing this on your paper and following along with me. And if at any point you can pause the video, do a step on your own, and please do that. So let's try another one. Let's try and do 1 3/8 times 2 1/2. Okay. Again, I'm going to have my 1 3/8 be on my section here with my rows, and my 2 1/2 is going to be over here, going horizontally like a column, like vertical column, but it's the horizontal part of my area model. So I'm going to separate 1 3/8 with the whole number 1 plus the fractional part 3/8, and that's what I'm multiplying times 2 plus 1/2. So I really have the quantity of 1 plus 3/8 times the quantity 2 plus 1/2. Now I can start my area model, so I have my 1 whole, and I have my 3/8, and I have 2 whole, and I have 1/2. And again, I'm going to multiply like an array. 1 times 2 is 2. 2 times 3/8 is 6/8. 1 times 1/2 is 1/2. And 1/2 times 3/8 is going to be 3/16. Alright, in order to find the product of these two mixed numbers, I now need to add together all of my partial products that are in the boxes. So here, this time I'm noticing that I only have one whole number, and I have 3 fractions to add. What I like to do is to circle the parts that I'm adding together so I know I don't miss any, because I know that I'm going to need a common denominator once again. So I'm going to be adding my 1/2 plus my 6/8 and my 3/16. And of course my common denominator here, well actually I won't say it, in case you want to take a moment to pause the video and create your equivalent fractions so that you can add those together. And if you're back with me, my common denominator here, or my least common multiple, is going to be 16. So I'm going to and then I can add these numbers together. I'm noticing that 23/16 is actually an improper fraction. So before I even add on to that 2, I'm going to deal with that improper fraction so that all of my fraction work is finished. How can I change an improper fraction into a mixed number? Well, I just add my 2 little division dots, and that reminds me that I do 23 divided by 16. So I'm going to do 23 divided by 16. I'll put it on one side. So the mixed number that I come up with is 1 and 7/16. Now I can add that to my other partial product, and I come up with 3 and 7/16. That was kind of a tricky one, because here I have 3 fractions that I needed to deal with, and I need to remember to make those common denominators. I also needed to remember to change that improper fraction number. Again, if you're ready to stop the video and move on, you can. But if not, we can do one more example together here. This one's going to really be a challenge one. Let's try doing 1 2/3 times 4 1/2. And again, I'm going to separate my mixed number into both their whole number part and their fractional part. So this would be 1 plus 2/3, and this would be 4 plus 1/2. And that's going to help me set up my area model. 1 whole and 2/3. 4 whole and 1 half. Then I'm going to just multiply. So I have 4 times 1 is 4. I have 4 times 2/3 is going to be 8/3. It's an improper fraction already in here. I'm going to leave that and deal with that later on. 1/2 times 1 is 1/2. And 1/2 times 2/3 is 2/6. And noticing that my denominators are 2, 6, and 3, and those are numbers that are pretty simple for me to find a common denominator. So I'll start by adding my fractions together. 8/3, 2/6, and 1/2. And again, you should pause the video and make your equivalent fractions a good common denominator, because this is something that we're confident with at this point. And if you're back with me, the least common multiple that we're going to use as our common denominator here is 6. Equals 216. 2/6 times 1 over 1. And 4 times 2/3. Now I can add together my fractions now that I have a common denominator. And I have 21/6. So 21/6, that's an improper fraction once again. So I want to change that improper fraction before I can add on to my other whole number. So let's do 21 divided by 6. 6 times 3 is 18. And 3 left over. So I have 3 and 3/6 is my mixed number, plus my 4 whole that I have for my partial product, by 7 and 3/6. And of course I need to reduce that to 7 and 1/2. Okay. At any point, if you can stop and try one of these on your own, you should. If you feel uncomfortable with the videos that we just did, I'd like you to go back, and now that you've written down your answers, try and follow again with some of the examples, and then go back and try that independent station and see how you can do.